A massive galaxy sits on the image exactly where it should. The structure is there. The scale is there. At first glance, it looks like the kind of system that should still be busy creating new stars. Then, the observations force a second look. The expected signs of star formation are missing. Not reduced, not fading, gone. That immediately creates a problem. Large galaxies are supposed to stay active for a long time. More size should mean more opportunity for new stars to appear. Yet some of these galaxies already seem quiet, while the universe was still relatively young. The problem is not that the galaxy disappeared. The problem is that it survived. The structure remains intact. Yet the process that should be creating new stars has already shut down. What was expected to continue is already over. The galaxies themselves remain massive. Nothing about their appearance suggests a collapse. But somewhere along the way, entire generations of future stars simply never appeared. And whatever can do that appears capable of acting far earlier than anyone expected. The simplest explanation still has one advantage. Maybe the galaxies only look inactive because something is being missed. Maybe the observations are incomplete. Maybe the signs of new star formation are hidden somewhere that has not been seen yet. Then the pattern keeps returning. A massive galaxy appears quiet. Another survey examines it and finds the same thing. A different observation looks again and reaches the same conclusion. The expected activity never reappears. What makes the situation harder to dismiss is not a single result. It is repetition. The same type of galaxy keeps showing the same behavior. Large systems that should still be building future generations instead appear frozen in place. The structures remain visible. The galaxies remain massive. But the process that should be creating fresh generations of stars is absent. Each new observation removes another escape route. The idea that astronomers simply overlooked something becomes harder to defend. The missing activity does not suddenly return when the galaxies are examined again. The silence survives. That changes the problem completely. The question is no longer whether something was overlooked. The question is why the next generation of stars never arrived. By this point, the silence no longer looks like a mistake in the observations. It looks real. And if it is real, then something removed a process that should have remained active for billions of years longer. The search for an answer eventually produced something that seemed to fit. At the center of many galaxies sits a supermassive black hole. Under the right conditions, it can release enormous amounts of energy into the surrounding region. Gas that might otherwise drift together and form new stars can be heated, disturbed, or pushed away. The visible consequence is straightforward. No cool gas means no fresh star formation. The raw material needed to build future stars becomes unavailable. The galaxy keeps its shape while its future population disappears. For the first time, the observations begin to make sense as part of a single process. The galaxies are still there. Their structure remains intact. If their own central regions cut off the supply needed for future stars, the silence no longer looks mysterious. It looks inevitable. That possibility changes the mood of the investigation. The problem no longer looks impossible. It starts to look mechanical. Cut off the fuel. Stop the next generation. The galaxy goes quiet. The fuel disappears. Future future stars never arrive. The galaxy keeps its shape, while its future quietly vanishes. The explanation feels strong because it matches what is being seen. Perhaps the galaxies did not simply go quiet. Perhaps their own cores shut the process down. The explanation works right up until it is tested against another galaxy. One galaxy contains a massive central black hole and stops producing new stars. That fits the model. The chain of events appears clear. Then another galaxy enters the picture. It contains a comparable black hole. It exists under broadly similar conditions. Yet new stars continue appearing. The expected pattern breaks. Researchers compare one system against another and find an uncomfortable result. Galaxies that seem similar on paper do not always share the same fate. Some go quiet. Others remain active. The contradiction is not subtle. The same feature that appeared capable of explaining galaxy retirement no longer separates retired galaxies from active ones. A massive black hole can exist in both. That changes what the observation means. The explanation still sounds reasonable. The problem is that reality refuses to follow it consistently. Similar galaxies keep reaching different outcomes. The moment comparable galaxies begin producing different outcomes, confidence starts to erode. A galaxy can contain the suspected shutdown mechanism and continue forming stars. Another can contain a similar mechanism and become dormant. The expected relationship no longer holds consistently. That is where the problem returns. The most convincing answer stops separating the quiet galaxies from the active ones. Knowing that a galaxy contains a massive black hole is no longer enough to know whether star formation will survive or disappear. Something important is still missing from the picture. And until that missing piece is found, the fate of an entire galaxy remains surprisingly difficult to predict. By this point, the picture looks less orderly than it once did. Some massive galaxies continue producing new stars for billions of years. New generations appear. The process continues, and the galaxy remains active. Others seem to reach a very different outcome. The structure survives. The galaxy remains visible, but the production of new stars slows and eventually stops, leaving behind a system that appears to have retired long before expected. What matters is not that a few unusual galaxies behave differently. It is that early dormant galaxies exist at all. Their presence shows that similar galaxies do not always live similar lives. Similar systems can move toward different futures. Multiple processes appear to be interacting, and some of the most important ones remain difficult to predict with confidence. The consequence reaches beyond any individual galaxy. The familiar assumption that galaxies grow, age, and slow down according to a largely reliable timeline becomes harder to trust. Observations continue revealing cases where the expected sequence does not fully match reality. A silent galaxy is no longer just a galaxy that stopped producing stars. It is evidence that galaxies do not all age according to the same schedule. Some continue building new generations for billions of years. Others appear to retire while much of their expected future is still ahead of them. The galaxy remains visible. The missing stars do not. What should have happened never happened, and that gap is becoming harder to explain away.